Here are a few examples of the fraction equations that have double fractions. Why not? So let's see, number A. The first step would be to get rid of these double fractions by expanding. So, for example, here we would like to expand with 4 to get rid of the x over 4, and that also gets rid of the x over 2 in the denominator. So let's expand with 4. It gives us x. The 1 becomes a 4, and down here the 1 becomes a 4. And x over 2 times 4 is twice x. And in this fraction, there obviously needs to be a factor of 2 that we include. So this gives us a factor of 2 in the denominator as well. And look, it's the same denominator as on the left-hand side. And the common denominator, we can find it. We could use 4 times 4 minus 2x, but we can actually make it a bit simpler by recognizing that there's a factor of 2 here. And now the common denominator is a wee bit simpler. It's just 4 times 2 minus x, not 4 times 4 minus 2x, which would be twice that. Yes. So we get a factor of 2 here. We get a factor of 2 minus x here. And we get a factor of 2 here. And we can just now delete the denominators. Remember that the domain is anything but 2. And we are left with a simple linear equation, 2x plus 4. 2 times x plus 4 is 2x plus 8. And here we have 2 plus 6 is 8 minus x. So we get x equals 0, which is in the domain. For B, we expand with w on everywhere. So we get w over w plus 1. And here we get w plus 1 over w minus 1. And let's apply the cross rule. First of all, the domain is anything except 1 and minus 1. And the cross rule gives us w minus 1 equals w plus 1 squared. And we expand and see what we get. And the squared terms simplify, which is nice. So we just have a linear equation. Minus 2w gives us negative 3w on the left-hand side. So w equals minus 1/3, which is in the domain. So there you go. Finally, for number C, this is a fractional equation, but it has the peculiar form that we've seen many times in polynomial equations. It is a product of 3 factors, which is 0. So this can only happen if one of the factors is 0. So we can apply the zero product rule just the same. And we can already simplify by saying, well, 1 over x minus 1 is 1, or 2 over x minus 2 is 1/2, or 3 over x minus 3 is 1/3. Now, how do we solve this? Here we get, well, first of all, the domain is anything except 1, 2, and 3. When we multiply away the denominators, we get 1 equals x minus 1, so x equals 2. In the second equation, we get 4 equals x minus 2, so x equals 6. And in the third equation, we get 9 equals x minus 3, so x equals 12. But be careful of these three. One solution is extraneous. So we get 6 and 12.